Good afternoon, everyone. Again, today we will have the different concepts regarding engineering mechanics. So, already in last lectures, we have seen the concepts regarding engineering mechanics. So, we have seen in last two lectures, we have seen the basics regarding engineering mechanics. We have seen the various concerns regarding engineering mechanics. We have seen the different laws, and in last lectures, we have solved the numericals related with the engineering mechanics, that is related with how to find out the resultant or how to resolve the forces in x and y directions, and depending upon x and y directions, how to resolve the forces, and depending upon that we have to find out the resultant of the different forces we have seen in last lectures. Again, to find out its magnitude and directions we have seen. Okay, so again, the next bit related with the mechanics is nothing but the equilibrium. Again, most important is equilibrium concept is also very important. uh, Equilibrium is nothing but, it is nothing but a state of a body at rest. Okay, when number of forces are acting on a body, and when we are drawing a free body diagram for it, and the number of forces acting on a body in such a way that we have to resolve all the forces in such a way that the body it is to be in equilibrium. There should not be any effect or any deformation in the body or any effect in the body, and we have to design in such a way that we have to provide reactions in such a way that it should not bend, it should not deform the body, and the effect on the body of all the forces will be zero. Okay, in this case the body will be at rest. That means there will not be any change in its position. It will not be, it will not have any change in its position. That means the body it is in equilibrium. Okay, so when the body it is in equilibrium, that means in order to have the body it is in equilibrium, we have to resolve along x and y directions. That means what it says in for a 2D, when the body it is in equilibrium in 2D, two-dimensional figures, that means it is having only two-dimensional, that is x and y. The all horizontal forces we have already discussed how to find out the horizontal forces in previous lectures. The all horizontal summation of all horizontal forces acting on a body, it is to be equal to zero, and all the vertical forces acting on a body it is also equal to zero, and summation of all movement applied or movement we are taking at a particular point, here example is nothing but O. The summation of all movement at a point is also equal to zero. Okay, that is also equal to zero. So in this way, we have to find out the condition of equilibriums, that is the algebraic sum of the all horizontal forces along x. That is all horizontal forces, all vertical forces, and we have to find out the movement at a particular point. Okay. So here it has been along x and y directions. We have to resolve along x and y directions, and we have to take the movement also. Okay. The most important is we are taking the moments. The movement of all forces, summation of movement of all forces at a particular point is nothing but the it is nothing but but the resultant of all the forces, or all the forces in x and y directions, and movement about any point, it is to be equal to zero. Okay. Again, next is nothing but, there is an example here. Here there is an arbitrary shaped body is there, in which the number of forces it has been acting. Okay. Here f1 forces it has been acting, f1, f2, f3, and f4. So we have to find out what is its effect of the different forces on this body. There is arbitrary shaped body is there, in which number of forces are acting along xy direction, that is f1, f2, f3, and f4. These are the four forces which has been acting on this body. So first we have to find out what is the resultant of all these forces. We have to find out the resultant of all these forces. That means we have to resolve all these forces and convert this all four forces into a single force. That means we have to convert this all forces into a resultant force. Okay. So consider IBD of an arbitrary shaped body. All the forces on the IBD may be replaced by an equivalent, that is a resultant force. So resultant, R stands for resultant force. So RF, that is a resultant force, that is equals to summation of F acting at a point A, and a resultant movement we have to find out, because we have to find out its movement also. What is the movement of this all the different forces on this body? So we have to find out the movement of all the forces, all the resultant are at a point A. Okay? That is nothing but equals to summation of movement of moment of all the forces about point A. That means summation of all movement about A, that is the movement of all forces about A, that is equals to 0. Here we have converting these all four forces into a single force, and we have also find out its movement, its directions, at where what point it has been acting. We have calculated its directions also. Here is again the procedure for analysis of in order to calculate the equilibriums, or in order to calculate the effect of the various forces on a body. So what are the different procedures to be followed? The procedure for analysis is nothing but, first we have to draw the free body diagrams, that is FBD. What is body diagram? We have to release from the different supports. We have to release the body from the supports. We have to release the body from is there any support or so we have to release the body. Okay? So free body diagrams, we have to find out, we have to establish the x and y coordinate axis in any suitable orientations, and also we have to find out outline shape of the body. We have to find out its when the different forces are acting, if number of couples are acting, or if movement is acting on a body, then we have to draw a BD of the different forces and movements and its effect along x and y directions. We have to find out its specify their directions related to x and y directions. Okay? So first, in order to solve the equilibrium problems, first we have to draw the free body diagrams depending upon x and y directions, and then the different forces acting on a body. We have to resolve the different forces acting on a body along x and y directions, and we have to take a movement and to find out the resultant of the all the forces. Okay? Again, procedure for analysis same. That is in first we have to find out its magnitude and direction of the different forces. The sense of force or a couple movement having unknown magnitude, but known line of actions can be assumed. Here, line of actions along the same line of actions where it is having some magnitude, unknown magnitude is there. We have to find out along the same line of actions. We have to find out and indicate the dimensions of the body necessary for completing the movements of forces. If there are any dimensions is there, the we have to specify the dimensions in order to take the movement about a point. Okay? So here is there is an example for in order to find out the various. First, we have to resolve these forces. First, we have to release this beam from the various support conditions, roller and hinge conditions. So before that, we will have some basics regarding, again more basics regarding the engineering mechanics. So here there is, yes. So we will solve the problems related with engineering mechanics. Some different problems related with engineering mechanics. Yes. So here we will have equilibrium conditions. As I've already said that we have to first draw the FBD diagram, that is the free body diagram for this case, and we have to find out the resultant. When the resultant of the force system acting on a body is zero, we use the term as equilibrium. When all the forces acting on a body, and there is no, we have to solve when different forces acting on a body, what is the effect of the different forces acting on a body in order to have the body in a equilibriums. Okay? For that we have to draw the free body diagrams. That means we have to isolate isolated figure to be drawn depending upon the various if there is a support conditions is there, we have to remove the support conditions. We have to remove all the support conditions, and we have to draw the FBD, that is the free body diagram for this. So there is an, here there are the different supports are there. First is nothing but the roller support is there. It has been represented in this way. So we have to release this. There is a beam which has been supported by roller support. The roller support, it is having only one reactions. Again, while applying the reactions on this support, we have to apply this along a particular perpendicular directions. So here this roller it is in horizontal. Therefore, we are applying it in a perpendicular direction, that is the RA. The roller, it has been moving in horizontal directions. It is moving in horizontal directions. Therefore, we are applying a reaction in a perpendicular directions. Okay? We are applying a reactions in the perpendicular direction, that is in vertical directions. Okay? So A point is there. Therefore, we are providing RA. Whereas again, roller on inclined surface is there. This roller is moving in this inclined directions. It is moving from up and inclined directions. therefore we are providing a perpendicular in the inclined directions. Okay, it is making an angle of 90 degrees. There is in some cases there may be inclined rollers also. In some cases there may be a horizontal roller also. Okay, the hinge support is there. There is a hinge support in which a hinge support always it is having two reactions. When we will release this hinge support from a beam, that means there are two reactions. In roller supports there are only one reactions because it is moving in only x directions. It can be it is moving in x or y directions. So here in this roller, it is moving in x directions. Therefore, it is having perpendicular in y directions. But in hinge, it is moving in x and y directions. Therefore, vertical directions. We are applying a reactions at this point, and we are applying reactions at A. That is nothing but vertical reaction at A and horizontal reactions at A. Again, fixed end moments. Here this support is it has been fixed when while releasing this beam along this fixed supports. That means there will be horizontal reactions also, there will be vertical reactions also, and there will be a movement created here. Okay, because in fixed supports there may be rotation. Therefore, in order to resist the rotations, therefore there will be a movement applied here. Vertical directions we are applying a force, horizontal directions also we are applying a movement here. Okay, again there is a bar which has been resting on. There may be a pit, or there may be a container in which a bar it has been resting. So we have to first draw the FBD for this. We have to draw a perpendicular here. So while drawing the perpendicular, there may be a 90 degrees. It is to be drawn normal to this bar. So here normal at point B we are drawing this at making an angle of 90 degrees. Again here it has been in contact here at this point there is only one contact, therefore we are drawing only one perpendicular. But in this case it has been in contact with horizontal directions as well as in vertical directions. It is in contact with horizontal as well as in vertical directions. Therefore we are having two reactions. There is horizontal reactions as well as vertical reaction. So depending upon whether the bar it has been laid horizontal on the horizontal surface, or it has been laid along the vertical as well as the horizontal surface. So here point A it has been in contact with horizontal as well as vertical surface. Therefore we are providing two normal reactions. Here in this case it has been only one contact surface is there. We are providing a only one normal reactions here. Okay. Again there is a ball and socket joints. These are very important while releasing or while drawing the FBD diagrams. These conditions are very important. That is support, it has been a roller support or hinge support or fixed support. Depending upon the conditions we have to first find out the reactions depending whether roller it has been provided or hinge or fixed support it has been provided. So depending upon that we have to solve the problems. Okay. Again ball and socket joints. Again, ball and socket joints, it is having in contact with all the three along x, y, and z directions. It has been inclined, therefore, it x direction it has been in this way inclined directions. Wow. In perpendicular, it has been RZ directions because it is in contact with all the three that is x, y, and z directions. Okay. Again, there are two balls which has been kept in a containers. Again, simple way a ball it has been in contact with the vertical wall. It has been in contact with the this first wall. It has been in contact with the vertical wall as well as at the bottom surface, floor surface, and it is in contact with both. Okay. So after releasing or after drawing the FBD, again this second smaller wall it has been in contact with the vertical wall, and it has been in contact with each other. Okay. So after releasing this, after drawing this IBD, we have to release it from the support, whether it is horizontal support or horizontal floor or vertical wall. And we have to release again normal reactions at point B, normal reactions at A. It is to be it is perpendicular to the surface. Therefore, it is horizontal surface. We are providing vertical. It is vertical surface. We are providing horizontal. And this is nothing but the weight. W stands for the weight of the first ball. That is W1. Again, there may be contact surface. So this contact surface there it has been inclined when releasing from this. So there will be reactions at the contact surface C. The NC is there, and it is towards the point. It is towards the point. Okay. Again, W2 is the weight of this smaller circle, smaller wall. Whereas after releasing from this vertical wall, there may be a normal reaction at D. So normal reactions is nothing but perpendicular to the surface. It is normally perpendicular to the surface. So here most important is while drawing the free body diagrams, we have to see whether the surface is horizontal, whether the surface is vertical or inclined. So depending upon that, we have to draw the free body diagrams. Okay. Again, important concepts related with this is nothing but the Lamy's theorems. Okay, because Lamy's theorems is also very important. So Lamy's theorem is again depending upon this. We have to first use the Lamy's theorem. Lamy's theorem is nothing but if three non-coplanar forces acting on a body towards or away. Here in this Lamy's theorems, there are the three coplanar forces because non-coplanar forces are there, but they are acting away from the points. If three non-coplanar forces acting on a body towards or away, but in this case, these forces are acting away from the point. Keeps the body in equilibrium, then each force is proportional to the sine of angles. So what this Lamy's theorem says, so each force is equal to the sine of angle. Then each force is proportional to the sine of angle between the other two forces. That means if this force is P, and what are the different other two forces? The forces R and Q. So what it says? So P is directly proportional to the sine of angle between the two is nothing but sine of alpha. The P is directly proportional to sine alpha, whereas Q is directly proportional to sine of beta, whereas R is directly proportional to sine of gamma. Okay. But after solving this, so P upon sine alpha that is equals to Q upon sine beta and R upon sine gamma. So what is Lamy's theorems? Lamy's theorem says that when non-coplanar forces, but we have to keep one thing in mind. This Lamy's theorem can be applied only when three forces are applied. If number of forces are more than three, then this Lamy's theorem cannot be applicable. Okay, so it is applicable when only three forces are acting on a body, and non-coplanar it is towards the point or away from the point. It doesn't it is not as important, but only most important is three forces to be acting on a body. Here sine of angle between the two forces, that is P is directly proportional to sine alpha, Q is directly proportional to sine beta, and R is directly proportional to sine gamma. But after simplification, it comes to be P upon sine alpha that is equals to Q upon sine beta or R upon sine gamma. Okay. Again, rectangular types of loadings is also important while solving the problems related with this. Types of loadings are also important because if we are finding out the different depending upon different loads, whether it is uniformly distributed load is given or whether it is a UVL, that is uniformly varying load is given, so it is to be divided or convert this UDL into a point load. Okay. So here rectangular loading is it has been given, that is it is in uniformly distributed load. It has been given, it is having an intensity of W Newton per meters. The intensity of this UDL is nothing but W Newton per meters and acting at a span of length L. Okay. So it can be given in this form, or it can be given in this form also. Okay, which is having a the height for this figure or this rectangular surface is same. Okay, throughout. How to find out the intensity for this UDL? The same simple way is nothing but if we are converting this into a rectangular surface, what is the area of the rectangle? Area of rectangle is nothing but length into width. Okay, here length is L. What about the width? Width is W. Okay, width is here intensity for this UDL is nothing but W. So the W into L into W or W into L, one and the same, and it will be acting at the centers. If we are finding out the CG for this rectangular part, so CG will be acting at the center. Okay, so it will be acting at the center. So here L W into L will be acting at the center, that is nothing but the L by 2 into L by 2 and L by 2. So here we have converted this UDL into a point load and its intensity is WL, and whereas it is acting at the center of the beam L by 2 and L by 2. What about the unit for this W into L? It will be converted into a point load. That means what is the unit of the point load? The point load unit is nothing but newtons. Okay. Here intensity for this it was Newton per meters multiplied by meter get cancelled. So what is the unit of this point load? So here unit for this point load is nothing but newtons. Again, triangular loading is also important because in some cases triangular loading is also given. So here starting A point it is having a zero intensity, whereas at B point it is having a maximum intensity of W Newton per meters. W is Newton per meters. So at A point it is 0, but at B point it is maximum, that is W Newton per meters. So we have to convert this triangular loading, or it is also called as UVL, that is uniformly varying loading, into a point load. So most important is, while converting this into a point load, we have to convert this into a point load by applying what is the effect of this triangular load and where it is to be applied. So what is the effect of this triangular load? That means this area of the triangle we have to take. What is the area of the triangle? That is half into base into height. The half is nothing, base is nothing but length, and that is L is the length, and height is nothing but the intensity W. But where it will be acting? So it will be acting at the CG. Here also we have acted upon at CG. So here also triangular loadings, this will be acting at the CG. So how to find out CG? So first we have to draw a parallel line over here. Here it is parallel line, is it has been given. So here parallel to this we have to draw again a line, parallel line, it is to be drawn, and we have to find out the distance. So here distance is nothing but 1/3 of length and 2/3 of length. Okay, here we have taken as 1/3 of length and 2/3 of length, because the maximum height it has been at B. So we have drawn, we have find out the CG from B. Okay, from point B. So it is 2/3 of L and 1/3 of L. After adding this, it comes to be total as length. Okay. What about its intensity? Intensity is nothing but half into base into height. That is base is L and height is W. Again, it has been measured in newtons. Okay, and it is acting at 2/3 of L and 1/3 of L. How it has been acting? According to the concept of CG, that is the center of gravity, the whole mass, the point at which the whole mass it is supposed to be, acquired. It is nothing but the point at which the whole mass is supposed to be accumulated is nothing but the CG. Okay. Here triangular loading, the point it has been acting at this point here. This at this point the whole mass it is supposed to be accumulated. Again, the same criteria, we have reversed this figure in which A was 0, here was A is maximum and B is 0. Again, CG will be, this maximum is here. So therefore, we will draw and we will have the CG from the point A, because this maximum part is here. So we will have this 1/3 instead of here. We will have this 1/3 as here, 1/3 of length and 2/3 of length. How to find out intensity? Intensity is same, half into base into height. Again, trapezoidal loading is there. Trapezoidal loads are there, in which it is having a varying load. Here W1 is a load and W2 is the another load. Okay? So there are the two waves in this, or this trapezoidal loading. It is having a combination of two loads. That is, if we have drawn a line here, so that means it will be converted into two figures. Next, bottom figure will be the rectangular figure, whereas the top figure it will be a triangular figure. Okay, so rectangular figure, already we have drawn this rectangular figure, L by 2 L by 2. And what about the triangular figure? So triangular figure, it has been same as this. Okay, that means it is having two intensities, L1, W1. It is the height for this smaller triangles. What about the height of the larger triangles? That is W2 minus W1. So here we have taken as W2 minus W1. That is the height of the triangles. Okay, and where it is to be acting? It will be acting at the CG. Okay, so here CG for this figure is nothing but L by 3. For the second load, it is L by 3 and 2/3 of length. What about the first figure, rectangular figure? It is having intensity of W1 into L, and it is acting by L by 2 and L by 2. That is the combination of rectangular figure and the triangular figures. In this, there is a combination of rectangular as well as the triangular figure. Again, these are the conditions for equilibrium. Already we have discussed in slides. That is the summation of all forces along x directions, y directions, and the movement of all forces at a particular point that we are considering as point as O. Okay. So here these things to be taken care. We have to first find out the summation of all horizontal forces. Then we have to find out the summation of all vertical forces, and then we have to find out the movement at any point. We are assuming as point O. Okay. Again, most important is to calculate two unknowns. Two equations are required, and three unknowns and three equations are required. That means out of these three equations, if the unknowns are three, that means all the three equations will be used. If the unknowns are two, so out of these three, any two equations will be used. Or if the unknown is one, out of these three, any one equations will be used as per the requirements. Okay. So depending upon the number of unknowns, these equations will be used. The equilibrium equations will be used depending upon the number of unknowns. So So here there is a simple figure in which we are first the end conditions. We have to see the different end conditions. Here this problem can be asked depending upon the different end conditions. First we have to release the supports. The first we have to draw the FBD, that is the free body diagram for this, in which this support A is nothing but hinge and support B is having a roller support, and both are acting horizontally. Okay, this roller is also moving in horizontal directions, whereas this hinge, it has been applied in horizontal way. Okay, it is not applied in vertical or inclined way. This hinge is applied in horizontal way, and this roller is also moving in horizontal directions. What about this force? 4 kilonewton, it is vertically downwards acting. 8 kilonewton, it is making an angle of 30 degrees with this beam, with this bar. Okay, and the distances are 3, 3 and 2. That means this it doesn't require the resolution for this force 4 newton, but we have to resolve 8 kilonewton along x and y directions. So we will resolve this along x and y directions, and it is making an angle of 30 degrees with the horizontal. That means horizontal component will be cos theta and vertical component will be sin theta. Also about this hinge support, after releasing the support, hinge will have two reactions. First it will have in vertical directions, next it is perpendicular to this is nothing but horizontal directions. So vertical directions and horizontal directions, it will have two reactions along this point A, and along B there will be only vertical reactions, only one reactions. Okay, so here we have drawn this BD for this case, in which we have resolved this 8 kilonewton. It is making an angle of 30 degrees. So here it is 8 cos 30, and here it is vertical as 8 sin 30. And after releasing this hinge supports, it has been in vertical directions here, and also here there will be an horizontal direction. What about this support B? It is in roller support, therefore it will have only one reactions. Okay, it will have only one reaction. Again, depending upon this, first we have to find out how many numbers of unknowns to be calculated. Here we have to calculate 1, 2 and 3 numbers of unknowns. That means all the three equations will be used. So here first while finding out the unknowns, first we have to take such equations in which number of unknowns to be calculated easily. Okay, here number of unknowns are here horizontal reactions at A, vertical reactions at A, and the vertical reactions at B. In this way, one, two, three numbers of unknowns are there. That means three conditions are required in order to find out the values for these unknowns. Okay, so here already we have attached this in supports. Now first we have to find out the simplest way in order to calculate this. So first we will see the figures in which there are two vertical unknowns. So this requires time for calculations, but we will see horizontal. So horizontal, there is only one horizontal force, it is unknown, whereas this 8 cos 30, it has been given. Okay, that means this horizontal force will be calculated faster as compared to the vertical force. So first we will have the simpler calculations to find out this horizontal force, because in vertical there are two unknowns, whereas in horizontal there is only one unknown, and we can easily find out. Okay, so here we are first using the equilibrium condition as summation of fx is equals to 0. That means all horizontal forces about any point, it is equals to 0. Okay, so summation of all horizontal forces. You'll see in the figure how many horizontal forces are there. So here only there is one force is there which is moving rightwards, whereas 8 cos 30, it is moving left side. That means it has been balanced. It has been balanced. So that is AH plus and minus of 8 cos 30. So here we have taken as AH and minus 8 cos 30. That means AH value, it comes to be simple multiplication is there. It comes to be 6.928. It comes to be 6.928, that is in kilonewtons. So in this way we have calculated the horizontal force. Once we have calculated the horizontal force, we can find out the vertical force also. Okay, so but here in this case vertical force are two unknowns, so therefore we cannot take summation of fy is equals to 0, because y along the y components there are two unknowns. Okay, so there are three equations: summation of fx is equals to 0, fy is equal to 0, moment. So we cannot take y because there are two unknowns. We will take the third equation as moment is equal to 0. The summation of all moment about any point is equals to 0. So while taking the moments, one thing it is to be taken care. We have to take a moment at a point where maximum numbers of forces will be 0. We can take a moment about A also, or we can take the moment about B also. Okay, but we will take the moment about a. Why? Because this here the maximum number of forces will be zero, and the forces as compared to b, it is more. Here there are two number of forces are acting, but here in b only one force is acting. Therefore we'll take the moment at a. All forces are all forces about a, that means ah will be zero and ab will be also zero, because we are taking moment at this point. Therefore horizontal force about a will be zero, vertical force about a will be zero. We will take this moment about a. So 8 sine 30 into 3 meters we will take the moment, and it will be in clockwise directions. Okay. Again this 8 cos 30, it is along the same line, therefore it will be 0. What about this 8 kilonewtons? Again it will be acting about a, that means 3 plus 3 is nothing but 6. What are the distance for this? Vertical force into horizontal distance, so distances is 3 plus 3, that is 6. So 4 into 6 will be again acting about a. What about this b acting about a? So it will have in anti-clockwise directions. Here it will be in anti-clockwise directions because we are rotating about a. So it will have it. It will be in anti-clockwise direction rb. What about the distance? So 3 plus 3, that is 6. 6 plus 2 is nothing but 8. That means rb distance is nothing but 8 meters, and it will be moving in anti-clockwise directions. So here in next case we have taken the moment at about here we have taken the moment about that is the point A. Here we have taken the moment about point A. Okay. So here the calculations after taking moment about point A, what is the value it has been calculated? The value it has been calculated as 4.5. Okay. After the simple multiplications, it has been taken as 4.5. What about next? After calculating movements, first we have taken fx. Next we have taken a moment about the point A. The last condition for equilibrium, because there are three unknowns is there. The third equation remaining was fy. So then in this case we can take directly the moment of all vertical forces, that is equals to 0. Okay. So here we are taking this all vertical forces at 0. So here we have already taken the equations, that is ay is vertical force minus 8 sine theta y minus, because it is in downward directions, minus 4 again the given load, it is in downward directions, and rb is the reaction which is in upward direction, that is equals to 0. But here we have calculated rb as 4.5. So here we can put the values as 4.5. So 8 minus 4.5, that is the value of AB. So AB, it comes to be 3.5 kilo newtons. So in this way we have calculated the value of AB as we have calculated the value for AB as 3.5 kilonewtons. Then we have to find out the resultant or the reactions at A, that is the combined reaction at A, because A is having two reactions. This A figure, because A is having hinge support, therefore what is the resultant effect of this two forces on point A? So this again we can calculate its effect on point A. So how to find out its effect on point A? The resultant effect of these two forces on point A is nothing but square root of horizontal force into plus vertical force. Square of horizontal force and vertical force. So here we have taken as resultant force or reaction at A is nothing but square root of AH square plus AB square. That comes to be, after square of horizontal force and square of vertical force, this what is the effect of this horizontal and vertical force on this point A? So this is, it comes to be 7.76 kilonewtons. What about its angle made by this that is the resultant reactions at A, that is 7.76. So vertical upon horizontal is nothing but slope is nothing but tan theta. Theta is equal to tan inverse of vertical upon horizontal. It comes to be 26.8. That means we are acting at this. Suppose this it is there is a beam here attached, in which vertical force is there, horizontal force is there, and this 26.8, it is making an angle with horizontal. It is making an angle with horizontal. What is the value for A? That is nothing but 7.76 kilonewton. So in this way we have first resolved the forces. First we have released the beam from supports, and next case we have resolved the forces. Okay. Again there is a simple problem related with the equilibriums is there. Again the most simple problems are there related with equilibriums condition. Again, there is a roller support at point A, and there is a hinge support. There is a little bit change in this here. There is a roller support at point A. In previous problem, at point A there was a hinge, and at point B there was a roller. But in this case, at A there is a roller which is moving horizontally, whereas there is B. Again, it is applied at horizontal directions. That means A will have only one reactions in vertical directions, perpendicular reactions in vertical direction, because this roller is moving in horizontal directions. Okay. What about B? B is having perpendicular into vertical directions and horizontal directions. It will have two reactions in vertical direction as well as horizontal direction, which is perpendicular to this rod. There is a rod, there is a beam. We have to apply a reactions perpendicular to this. Okay, vertical directions and horizontal direction. What about this loadings? This loading is called as UDL, that is uniformly distributed load. So we have already discussed in previous slides, that is how to convert this UDL into a point load. Okay. So here it is uniformly distributed load, as its name says. The distribution of the load is uniformly from first point to last point. It is uniformly distributed. So how to find out its intensity? So simple way, it is the intensity is 5 Newton per meters multiplied by the length. Length is nothing but 4 meters. So 5 multiplied by 4, that is 20, and it will be applied at the CG. So CG of this UDL will be at center, that is 4 meters. Half is nothing but 2 meters. So here it has been applied at 2 meters. What is its intensity? Intensity is 5 multiplied by 4, that is 20 Newton. It will be applied at center, that is 2 meters. 3 meters is same. This 2 meter is as it is, and this 3 meters as it is. We have released this hinge support. We have applied the two reactions, that is vertical reactions and horizontal reactions, whereas we have released this roller supports, and we have applied a perpendicular reactions, because this roller was moving in horizontal directions. We have applied in vertical directions. Okay. Again, how many unknowns are there? The same problem is once again repeated. The last problem we have solved, the same problem is there. Only the different thing in this case was the UDL, because here UDL was provided, uniformly distributed was given. So we have converted this into a point load, and we have applied at center. That is CG. CG of this figure was at center. Okay. The same calculations is there. 1, 2, 3 unknowns is there, in which two vertical and one horizontal is there. So vertical 2, it is difficult to calculate. So first we will take the condition as x is equals to 0. So what about the x? Is there any x force in this? So BH will be 0. There is no x force in this. So BH will be 0. What about the vertical force? Yes, there are two vertical forces. Before that, we have to use such conditions in which one vertical force can be easily calculated. So we will use the second condition as moment, and we have to while taking the moment, we have to see, or we have to keep in mind one condition, that we have to take the moment at a point where maximum forces is 0. So here at support A there is only one force, so we can take moment here also, but there is only one force. We will take the moment at B. Why? Because these two forces will be 0. Okay. So we have to take a moment at a point where maximum forces will be converted into a 0. We will take the moment at B, and we will rotate this 3 about B, and we will rotate this 20 Newton about B, and we will rotate this RA about B. So first we will rotate this about B, that is in anti-clockwise. So 3 multiplied by 3, but with minus sign. Again this minus, why minus? Because it is rotating in anti-clockwise direction. So minus 20. What about the calculations for this? Distance for this. So 3 plus 2 is 5. 5 plus 2 is nothing but 7. Again RA, it is moving in clockwise directions. About this, it is moving in clockwise directions. Okay. So we have to see the directions. So this RA is moving in clockwise directions. What about distance? Distance in this case is 3 plus 3 is 6, 7, 8, 9, 10, 11, 12. So RA distance is nothing but 12. So in this way we can calculate the vertical reactions. We have calculated the horizontal reaction, BH. The horizontal reaction in this case is 0, therefore BH is 0. Or vertical reactions we have taken by movement. So BB by movement is nothing but, yes, RA by movement is nothing but, we have calculated here as RA after this by taking moment about point B. Why we have taken moment about point B? Because B is hinge, and it is having maximum number of forces, that is horizontal as well as vertical force, and the maximum numbers of forces will be 0. We have taken the moment at B. In this way, RA is nothing but 12.42 newtons. The same value to be applied in this vertical equations, that is summation of Fy is equals to 0. We are putting the values of Ra in this equations. Therefore 23 minus Ra, that is BB. So BB, it comes to be 10.58. newtons. So BB, it comes to be 10.58 newtons. Again, there is some different cases there. Again, some different problems is there related with again the equilibrium conditions. Every case it is having some it's the every problem it is different from the previous problem, because depending upon the load conditions, depending upon how the different reactions it has been applied on this rod, or on these beams, we are calculating. Okay, so again, find the reactions at support A and B for the beam. Again, there is a beam here in which reactions, and there is this point A is hinge support, and what about this point B? B is having a roller support, whereas this 10 newton, it is making an angle of 30 degrees with horizontal, which is inclined. Okay, so, and there is a triangular loading, or it has been called as UVL, uniformly varying loading. Here at this point it is 0, and it is maximum, there is intensity is 5 newton per meter. So how to convert this triangular load into a point load? So here we will have the area of this triangle as half into base into height. The half into base is nothing but 3 meters, height is nothing but 5, the half into base into height, and it will be acting at the CG. So here vertical surface, or vertical here line, it has been at this point. So we will draw here, and the distance is 1/3 of this base and 2/3 of this base. So this triangular loading, its effect will be along the CG. It effect of this load will be along CG. So here, after converting this, the value comes to be half into base into height, that is half into 3 into 5, it comes to be 7.5. Again, it is acting at 2/3 and 1/3. So 1/3 of 3 is nothing but 1 meters, and 2/3 of 3, it is nothing but 2 meters. So here it has been applied at 1 and 2 meters. Again, we have resolved this 10 newtons along x and y directions. So here it is cos theta vertical as sin theta. Okay. Again, we have released the support A. We have released the support, the vertical reactions at A and horizontal reactions at H, at A. Again, we have released the roller support, that is a vertical reaction at B. The simple problem is there, simple same procedure is there, and simple problem is there. So in same sense, we will find out first. We will find out the horizontal reactions, because horizontal, it has been balanced here. So here we have assumed the sign convention. Here it has been right side, but here the force, it has been also right side. Therefore, equilibrium condition will not be maintained. Okay, the balance will not be there. So therefore, this AH will be taken in from left side. Why it has been taken left side? Because it is to be balanced with 10 cos theta. Okay, 10 cos theta is right side. So this loading conditions cannot be changed. These reactions we have assumed. So these reactions can be changed depending upon the answers. Okay, so here answer is, it is negative. So reactions will not be negative. The final answer should be positive. So here answer, it has been negative. Therefore, these reactions which we have assumed for AH, it is wrong. We have assumed AH as right side. So we will convert this, or we will change this AH as left side, and we will find out its value. So here we have calculated the values. We have calculated the value of A, resultant at point A, that is we have calculated, and same way we have calculated the theta, that is nothing but the vertical upon horizontal, and same way the theta, it comes to be 38.95. Always this angle, it is to be applied, or it is to be applied at it will be making along with the horizontal directions. Okay, so it will be along horizontal directions. Again, one thing to be kept in mind, that what about the reactions? Okay, so AB and AH, it is both. AB here, it is 8.66 we have calculated, and AB we have calculated as 7 newtons, and AH we have taken as 8.66. After calculations, we have taken as 8.66. Again, same way, there is a trapezoidal load is there. So here we will fastly have the concept of this, because same concept, it has been repeating once again. The same conditions are there. There is a hinge and roller condition is there. There is a point load in vertical direction, forward downward direction, but this condition is important. Here there is a trapezoidal loading is there, in which it is having an intensity of 2 newtons here, but here it is having a 5 newtons. So how to convert this into a UDL? How to convert this into a point load? That means it is a combination of two figures. That is, if you are drawing a line here along this line, if you are drawing a line here, so that means this part is bottom part is nothing but the rectangular part, and upper part is nothing but the triangular part. So first we have to convert this rectangular part into a point load that is acting at L by 2 and L by 2, that is 1.5 and 1.5. What about the intensity? So 3 multiplied by 2, that is 6. Weight multiplied by its length, total length, that is 3 multiplied by 2, 6, and it will be acting at 1.5 and 1.5. So here it is acting 6, 1.5 and 1. What about this triangular loading? So 5 is the total load and 2 is the height. So what is the remaining height for this triangle? So 5 minus 2 is 3. So 3 is the remaining height. How to find out its intensity? So half into base into height. Base is 3, height is again 3. So half into base into height, it comes to be 4.5, and it will be acting at the CG. Okay, it will be acting at one third of this base, so one third of 3 and two third of 3. That means here we are acting as one third of 3 and two third of 3. Okay, here the distances for this is 1 meters, and here distance is nothing but 2 meters. So here we are 4.5, it has been acting at 1 meters, and this addition is 2 meters. Okay, one third of 3 and two third of 3. Two third of 3 is nothing but again 2 meters, one third of 3 is nothing but 1 meters. So it is acting in this way. 4.5 is the intensity for this top triangles. Here the intensity for this top triangle is nothing but we have calculated the height as 3 meters, 3 newton per meters. The half into base unit height, it comes to be the 4.5 newtons. So here 4.5, it has been acting at 1 meters and 2 meters. The same simple calculations is there. We have converted this into a rectangular load, and depending upon that, we have calculated the again the triangular loadings. Again, we have to find out the after converting this into figure. First, we have to see the hinge support. Hinge support, it has been acting at horizontal and vertical directions. Where what about the roller support? Roller support, it is having only one vertical directions. Okay. So here we will find out the unknowns. Here unknown in this case is 1, 2, and 3. That means there are 3 unknowns is there. So how to find out the unknowns? So first we will find out the unknown as horizontal reactions. Why? Because there is no as such horizontal force it has been given in this figure, and whereas vertical there are 2 verticals, so there it is very difficult to find out. So first we will have the calculations in horizontal directions. The summation of all fx is equals to 0. Then we will have movement about the point A, and then lastly we will have the fy as 0. Here calculations it has been done. Fx is 0, that is ah is equals to 0. Fy we have taken, but here equation has been formed, and calculations and movement about point A we have taken about point all forces about point A. So it comes to be rb, it comes to be 7.27, that is newtons. After the we are putting this value as rb in this equations, we can easily find out the vertical reactions at A, the av, that is vertical reactions at A. After putting the value of rb in this equations and subtracting from 20.5, it comes to be av as 13.22 newtons. Again, this concept is again important in some of the numericals or some of the problems related with this. Again, there may be this bracket, it may be given. Okay, what this bracket indicates? This bracket indicates it is having a base of 0.6 meters, and height is also there of zero point 0.5 meters, and base is also of 0.5 meter. And this assembly is nothing but a bracket, okay, in which the load it is acting at some height. Okay, it is not directly acting on a beam, it is acting at some height. Okay, what about this height? Height is same as 0.5 meters. What about this distance between this point and this point is nothing but again 0.5 meters. So first we will have the couple. What is the definition of when two like forces? When two like parallel forces. When two like parallel forces are acting at a point, that forms couple. See, so we have to convert this 30 newtons into a couple. So we will apply here vertical force, vertically downward force, and vertically upward force, which will be acting at this point. So we have drawn this figure for this. Yes. So here we have drawn this vertical force and horizontal force at this point A. and this two loads it has been applied here, vertical force and horizontal force at this point A, and we will take this moment 30 into point 30 and 30, that is 30 into point 0.5 will be movement, and this vertical force will be directly taken care. Okay, it will be directly dropped down and it will be used. Okay, so here we are converting this bracket into a couple as well as a vertical force which is acting at this point. Okay, at this point, so it will be converted into a couple which is having an intensity of 30 into point 0.5, whereas a point load it has been acting at this point. So here we have released the supports and we have converted this bracket into a couple and point load. Okay. So after that, we have the same concept it has been used to solve the problem. So again the same way, RA and RB it has been calculated, and reactions we have calculated, vertical reactions at A and H we have calculated. Again different case we have taken here. Yeah, again the somewhat different cases given, in which here there is a moment which has been acting at point C. Yeah. Here the intensity of this moment is nothing but 5 Newton meters, and what about UDL? UDL in this case is nothing but 3 Newton per meters, which is having a length of 2 meters. What about this 10 Newton inclined force? It has been acting, which is making an angle of 30 degrees. Again, support A is hinge and B is having a roller support. Okay. First, we will release the point A and B. Support. We will release the supports at point A and B, and we will resolve this 10 newtons along horizontal and vertical directions. So this 10 newton it is making angle with 30 degrees with horizontal. The horizontal component will be cos theta and vertical component will be sin theta. After resolving this UDL 3 Newton per meters, we will convert this UDL into point load. So 3 multiplied by 2, that is 3 to the 6. 6 Newton will be the intensity for this, and it will be acting at center, that is 1 meters and 1 meters. So here we have drawn this figure. First, most important is first we have to draw the FBD diagram for this, depending upon the loads, whether it is UDL or UVL or inclined loads or moments. And by releasing the supports, we have to first draw the FBD. So here we have drawn the FBD. Here we have drawn the vertical force at point A. Here we have drawn the horizontal force at point A. Here we have resolved this 10 Newton into horizontal and vertical directions. So here 10 cos theta will be there, and here it will be 10 sin theta. What about this intensity? 3 into 2, that is 6 newtons. This Newton meter will be converted into newtons. Why? The Newton meter multiplied by meter is meter, and meter get cancelled. So what is the intensity for this? It comes to be 6 newtons. It will be acting at CG. What is the CG for this figure? That is 1 meters. What about movement? Movement is same, acting at this 2 meters, and remaining 3 meters is having a point B. So B is having a roller supports. So only one reaction is there. Again, the same concept it has been repeatedly used, but here in this case, one extra concept we have used here. That is here in this case, couple it has been provided. Okay, movement or couple it has been provided. So we will use what is a here while one thing it is to be kept in mind while taking movement of this couple, while taking the movement of this couple, that is 5 Newton per meter. What is the unit for this couple? It is Newton meter. That means meter it has been already multiplied. That means this 5 it is including the meters. That is the distance. So while taking the movement about point A, so we doesn't have to take this distances 3 plus 2 plus 2 or plus 2. We will not take in case of 5 Newton meters, because in this case meter it has the distance it has already been taken care while calculating the couple. What is the couple, or what is the moment when two like forces or when force into perpendicular distance? That means distance we have already taken care. In this case distance is already taken care. Okay. So first we will have the x component, because x it is having only one value. Again this horizontal force we have assumed horizontal as right side, and this load it is the right side. That means this value it is to be it is not in equilibrium condition, it is not in balance condition. So therefore we will assume, or we will have this value as minus. So therefore we will change this AH as left side. Okay, we will change this direction for AH as left side. Okay. So here it has been minus sign, so we will change as left side, or we can have AH as minus 8.66. 10 cos theta simple calculations is there, that is comes to be 8.66. Same way Fy we have taken summation of all Fy, that is equals to 0. Before that we will take the moment at point A. Why? Because the number of forces here it is more as compared to B. So B is in roller conditions, whereas A is in hinge condition. Therefore we are taking moment about A. we are rotating this 10 sine theta about a, or what about this 10 cos theta about a, because along the same line of action is there principle of transmissibility. What the principle of transmissibility says, along the same line of action, this 10 cos theta is acting. That means this 10 cos theta about this point a will be 0. So we'll have only 10 sine theta about this a, that is 3 meters, 6 Newton about this a. So this it is having a distance of 1 meters plus 2 plus 2, that means 6 meters. So 6 multiplied by 6 will be acting about a. What about this 5 Newton meters about a? So 5 Newton meter, it will not be multiplied with the distances. 5 Newton meters, so that means we will take directly as 5. What about this RB? That is unknown, so it will be in anti-clockwise directions. So it will be in anti-clockwise direction. What about the distance for this? So 3 plus 2 is 5, 5, 6, 7, 8, 9. 9 plus 3 is nothing but 12. So in this way, we have calculated RB, and depending upon RB, we have calculated the remaining values. Okay. Again, the value of the resultant at point hinge support we have calculated, and its directions also we have taken care. Okay, we have taken care about the directions also. So its value comes to be 36.16. Again, here there is somewhat different cases there, in which there is a UDL with two inclined loads are there. Okay? Here this load is making an angle of 60 degrees with horizontal. Here this load is making an angle of 30 degrees with horizontal. Here A support is hinge support, whereas this B support, it is having a roller support. But this roller is moving along an inclined plane which is making an angle of 30 degrees. Okay? This roller is moving along an inclined plane which is making an angle of 30 degrees with horizontal. Okay? So we have to apply perpendicular, which will also be acting at 30 degrees. Okay, so perpendicular we have to draw. We will draw this, and we will transfer this 30 with vertical, because while drawing a perpendicular, we will transfer this angle made with horizontal will be transferred to the angle made with vertical. Why? Because we are drawing a perpendicular. Okay. So this angle made with horizontal will be transferred here as angle made with vertical. So here we have transferred this horizontal as this horizontal 30 degrees with the vertical as 30 degrees. Again this as it is been transferred after transferring, but it is a ruler, even though there is a ruler support, but it is inclined, so it is resolved in two directions. Okay, it is resolved in two directions. It is making an angle of 30 degrees with vertical. So vertical will be cos theta and horizontal will be sin theta. Same way 10 cos theta, it is inclined, making an angle of 30 degrees with horizontal. So again 10 cos theta, 10 or cos 30, and 10 sin of 30 with vertical. Again 20. How this UDL will be converted into point load? 5 plus 4, 5 multiplied by 4, it is 20. It will be acting at the center, that is 2 meters. Here we have taken as 2 meters. Again this cos 30, 15 cos 60 will be there, and 15 cos sin 60 will be vertical. After releasing this hinge, there will be two reactions here, vertical reactions and horizontal reactions. So again same procedure is there. First we will find out the horizontal reactions, then we will find out the vertical reactions, because horizontal unknown is 1 and remaining are known. This 15 cos 60 is known, 10 cos 30 is known, and unknown is only in horizontal direction, that is AH. So we will have this AH first, Fx is equals to 0, then we will take a moment about A. Why? Because a hinge support is there, and or we can take the moment about B also, because A is also having two unknowns and B is also having we will take the moment about A. Why? Because AH and AV both are unknowns. So we will take the moment about A. Again 15 cos 60 is along the same line, therefore according to the principle of transmissibility, this 15 cos 60 will be 0. The effect of this 15 cos 60 about A point A will be 0. Again the 10 cos 30 about its effect on point A will be again 0, because along the same line it has been acting. What about this 15 sin 60? It is clockwise, 20 clockwise. Now what about distance for 15 sin 60? It is 3 meters. 20, it is having a distance of 5 meters. 10 sin 30, it is having a distance of 2 plus 2 is 4, and plus 3 is nothing but 7. Okay. What about this distances? Again RB sin 30, it is along the same line of action. That means according to principle of transmissibility, it will also be 0. What about this RB cos 30? It will be in anti-clockwise directions. So it will be in anti-clockwise directions. Okay? It will, when rotating about A, it will be in anti-clockwise. What about distance? Distance is nothing but 3 plus 2 is 5. Again 3 plus 2 is 5, that means 10 meters. So in this way we have calculated AH, AV and RB. The unknowns which has been given here, special case was given in which the roller was in inclined conditions, in which we have resolved or we have drawn a perpendicular, and this 30 degrees we have transferred to the verticals. Okay. So in this way, this concept was also important related with the inclined conditions, related with this inclined roller conditions. We have taken care, and we have calculated the reactions along A and B. Okay, support A and B. Again, these are the simple calculations for this. Already we have solved the problem, but here this ruler is again 30 degrees with horizontal. So here we can draw, and we will transfer this along the vertical directions. So we have transferred this along the vertical directions, but if it is along the horizontal direction, it will be 60. That is, we have transferred this the same by triangles, that is 30, 60, 90. So how this 30 degrees we have taken, so there is a simplicity for this. We have transferred, and after drawing the perpendicular, this it has been converted to 30 degrees. So in this way, we have cleared, or we have studied the concept of equilibrium. So we have studied the concept of different support conditions, different load conditions in today's lectures. Again, we will solve some more problems on equilibrium, or we will have some more different concept in next lectures. So today we will end this lectures. If anyone having queries or doubts, they can ask the doubts and queries related with the lectures. And tomorrow also we will have some more concepts related with engineering mechanics. So we will solve some more problems related with the engineering mechanics. Okay. So thank you. We will end the today's lectures. Thank you all.